Okay. In fact, we'll talk through this one together. Now, if you do need another copy of it, this is 4.3. I believe it's entitled Arc Length and Circular Motion. There should be some extra copies right over here behind Daniel, in that little filing cabinet there, if you do need one. Okay. So we started talking about this on Thursday because that was the normal class period after the PSAT. And before we go ahead and get into it, just a couple of housekeeping items. Okay, your next quiz is going to be on Thursday. And this material that we're talking about right here, the arc length, the area of a sector, the linear and angular velocity, that is what's going to be covered on the quiz Thursday. Okay, so we'll be getting ready for that. I'll probably go ahead and give you another review problem or something on Wednesday before we go ahead and take it. But your second exam, that's the big one. That's next Thursday. That's going to be next Thursday, the 25th. I'm going to go ahead and probably in the next couple of days start putting that test together. But you can definitely expect this material to be on there. And however far we get, probably more questions relating to the unit circle and beginning to evaluate some trig functions. Okay, but the closer we get to the end of the week and the test, I'll go ahead and talk to you about that. Your homework, I'm going to go ahead and give that to you today after we go ahead and finish with the lesson. I'm hoping we should have a little time in class to go ahead and work on it. We'll kind of see how that plays out. But it's due Wednesday. It's going to be due Wednesday, so that gives you a couple of days to go ahead and take a look at that. And then the rest of that I'll talk about when we get there because that's for the homework. Okay. So let's see here. Arc length is one of the concepts that we started talking about that Thursday. So S is my arc length. All I want to do is take the radius and multiply it by theta. But theta has to be what? It's got to be in radians. Okay. So we'll talk about the conversion again in just a second. Now, there was another idea called circular motion that we started looking at. We were talking about a lot of these different problems. So let's begin with angular velocity. Now, whether you're asked to find angular or linear velocity, always start the same way. I want to set up my first fraction, finding the number of revolutions over time. Okay, we always start out the same. Now, even if the problem isn't asking you for angular velocity or angular speed, go ahead and find it because you can't find linear without the angular. Okay, so it's always going to build upon itself. So the number of revolutions times time, but we like our angular velocity to be recorded in radians. So what was that same fraction that just shows up over and over again? 2 pi radians, there you go. 2 pi radians over 1 revolution. Okay, this is how we'll start every one of these problems. The very first thing that should always cancel is going to be your revolutions. So you have radians per time. This is what we call angular velocity. This is the speed at which the angle is rotating with respect to time. Okay? How fast that angle measure is increasing with time. And we like to use omega, this curvy W, to represent that. Now, once we have angular velocity, there was only one thing I needed to do in order to find linear. All you got to do is multiply by the radius. As soon as you have angular and you multiply it by the radius, not only because this has some unit of length, whether inches, feet, whatever, okay, the radians are no longer necessary. You now have linear. There you go. All you have to do is multiply angular times the radius and you have linear. And remember, V was the variable we were going to use to represent that. Okay, and I want to say, let's see here how far we got. We definitely did 4. And I got this set up. Did we go ahead and do 5? Did we not make it to it? Okay, so I'll just go ahead and take this off. I mean, I'm about to write it back up there in just a second. But we'll do this one, and then we'll go right back into the notes. I believe we only got 4 problems left after this one. So a carousel at an amusement park rotates 3,024 degrees per ride. Okay, so A, how far would a rider seated 13 feet from the center of the carousel travel during the ride? Okay, so you've got a carousel. If you're looking at it from above, it's going to be a circle, and you've got, different seats going out. So if a person were to be sitting right here, let's say 13 feet from the very center, okay, and the ride starts to go around and around and around and around, well, the question is, how far in feet will the person have traveled by the time the ride is over? That's what we're talking about here. Okay, well, this is just arc length, right? It's just a portion of the circumference, the complete distance around the circle. And this is our formula. The arc length S is equal to the radius times theta. All right. So do we have the radius? Yeah, it's going to be what? 13, because that's the distance the person is from the center, right? So that would be your radius, so we have that. We do have theta in degrees, but we need it in what? Remember, it's got to be in radians, so I'm going to go ahead and do this. S equals radius of 13 times. Now, I'm going to go ahead and multiply it by 3,024 degrees, but as I substitute in, I'm just going to go ahead and convert it. Okay, so I'll just go ahead and multiply this by what? What gives me radians? Pi over 180. Okay. And just as we've seen before, those degrees are going to cancel. So this right here, once I multiply 3,024 times pi over 180, that's the distance it's going to travel in radians. If I multiply the radius by that, you've got yourself your arc length here. So let's see what that is. Come on over here to my calculator. 13 times, oh, I forgot what that was, 3,024? Okay. And then parentheses, control divide, I'm going to put pi over the 180. Okay. And if you want to, you could have converted that to radians before and then plugged that value in. I'm just kind of taking care of it all at once. But how far would the rider have traveled? I'm saying about 686 feet, okay, for an entire ride, if they're 13 feet from the center. Okay, so about 686 feet. Okay, now B says, how much farther would a second rider seated 18 feet from the center of the carousel travel during the ride than the rider in part A? Okay, so now what? There you go. We're going to do the exact same thing. I'm just going to replace 13 with the 18. And I'm going to do it this way, just so I don't have to retype the entire thing. If I highlight it and push enter, well, then I can only change the one part I need to. I don't have to type the entire thing over again. It saves me a little bit of time. Okay. Now, would we expect this to be a greater distance or a smaller distance? Yeah, greater. The further you are from the center, the larger the circle you're going to create, right? Okay. So this person, 18 feet from the center, looks like they're going to travel about 950 feet. Okay. But we want the difference. How much further would a person seated 18 feet from the center travel than a person seated 13 feet from the center? So, yeah. So I'm just going to go ahead and use the values that are already in there. I'm going to highlight the 950 minus, highlight that 686. We're taking the difference. I'm subtracting. So I'm saying that person probably went about an extra 264 feet if we're going to the nearest foot. Okay, about 264 feet. If this wheel come back up. There we go. There we go. Questions? Okay, let's take a look now. Yes. How many kids I have? I've got 2 kids. James and Natalie. I can let you blow your nose outside real fast, but let's see how much time we have when we finish to go to the restroom. Those Kleenexes will be right there, sir. Okay, so these are the only 4 problems I have left, and I don't think they're going to take too long. Let's kind of see. Hopefully we'll have some time, like I said, in class to work on the assignment. Number 7, it says, find the area of the sector of a circle of radius 2 feet formed by an angle of 50 degrees. So this one gets us into our new topic. We want to find the area. And right before this, you've got the area for the sector of a circle. Well, arc length was just a portion of the circumference. Well, here, the area of a sector is just a portion of the circle's entire area. Okay, kind of think about, a pizza. If you were to take out a slice, that represents a sector. Okay, so let's see what we got here. It's 1/2 times the radius squared times theta. But again, just like arc length, theta's got to be what? It's got to be in radians, not degrees. Okay, so let's set up this circle. We got a radius of 2 feet, an angle of 50 degrees. So let's say that's about 50 degrees right there. So we're not looking for the distance of the arc created by that angle. I want to know how many square feet we're actually looking at here. Well, I have everything except that there's one snag. Yeah, it's in degrees. Okay, so the first thing, we got to change 50 degrees to radians. And we did that just a second ago. What was it? Pi over 180. See, the degrees are going to cancel. They're both divisible by 10, so I can cross off the zeros. So it looks to me like we're going to have 5 pi over 18 radians. That would be equivalent to 50 degrees. Okay, so now that I have everything, you just go ahead and plug it in. The arc length S is equal to the radius. Oh, shit, we're talking about arc lengths. We want the area, I'm sorry. We're still stuck on arc length. 1/2 the radius squared, so 2 squared, 4, okay? And then times theta in radians, 5 pi over 18. This is your 1/2 r squared times theta. You know, and as you're plugging in, you know, if you can simplify something like this, 1/2 of 4 we know is 2. So I'll type that in into the calculator, but again, I just wanted you to see the substitution. So let's see here. 1/2 of 4, which I said is 2. Let me get rid of this previous one here. Oops. Okay, so 2, and I'm going to multiply that by the 5 pi over 18. Okay, so 1/2 of 4, the 2 times that theta in radians. To 2 decimal places, I'd say we're looking at about 1.75 square feet. Okay. Would you guys agree? Okay. 1.75 feet squared. Okay. There we go. Yes. Oh, because I just went ahead and simplified it. Instead of putting in the 1/2 times 4, I just kind of took that and wrote 2. 1/2 of 4. I just simplified it. Okay. All right. And that's all there is to the area of a sector. Okay. You just take your items, you plug them in, and you simplify. Okay. Now, that's the only arc area of a sector that we have. The rest of these are kind of going back and revisiting arc length. Okay, so let's take a look at this problem. Memphis, Tennessee is located at 35 degrees 9 minutes north latitude, and New Orleans, Louisiana is at 29 degrees 57 minutes north latitude. Assuming that the radius of the Earth is 3,960 miles and the cities are lie along the same longitude, find the distance between the two cities. Okay, now it seems like a really complicated problem, but remember, it's just based off this formula. The arc length is equal to r times theta. So if it helps you out, maybe draw a picture to kind of help visualize what's going on. Now, do you guys remember a couple weeks back when we started talking about these, if we start rotating on the positive x-axis, okay, with the origin, the vertex of that ray, what do we call that? What kind of position? Remember, that was standard position, right? Okay, so let's go ahead and say that I start to rotate. The first one I'm going to come to is New Orleans because it has a smaller degree value. Now, even though this is in DMS, degrees, minutes, seconds, we know that it's going to be 29 point something degrees, right? So I'm going to go ahead and rotate that amount, okay? So this right here, I'm just going to go ahead and say that N for New Orleans. Okay, so this first measure that I rotated would be 29 point whatever the following decimals are. I actually haven't calculated that. And I'll show you why in just a second. Now, the other one, the other city is going to be Memphis, Tennessee. So we have to rotate a little further to get to him. M for Memphis. So this larger one right here, that represents the 35 point whatever values degrees we have. So roughly, I've rotated to get to New Orleans about 29 degrees, and then I've rotated about 35 degrees. Is everybody okay with that? Well, here's the thing. Imagine that these points are on a circle. You know, we have part of the circle that kind of curves all the way back around. What we're trying to do here is find the distance between the cities. Just this guy right here. I want the arc length. Okay. So that theta would be this one right here. So does anybody already have an idea about what we can do to find theta? We can subtract. If I subtract the measures of the two angles we have, that'll give me this one right here, right? But you'll notice they're in degrees, and remember for this formula, we want them in what? Radians. So I would do this. Remember it was Brandon who told me about this particular key on the calculator. If you push the button between 9 and your catalog, this one right here that's highlighted red, second row, second icon. That provides you the fill in the blank for DMS. I would actually go ahead and plug in the DMS values you have and subtract those. So it'll not only convert them, but it'll also give you the difference at the same time. Bless you. So the first one I believe was 35.9, right? And there's 0 seconds, but I'm going to go ahead and put that in. You don't have to. Minus, then I'm going to push the same button here, same icon, and I believe it was 29.57. Okay, 57, I'm going to go ahead and put 0. Now, just because of my calculator settings, I'm going to go ahead and push enter. So it's giving me 26/5. Now, if you really want to see the decimal, you can hit Control Enter. Okay, and it'll also go ahead and give you 5.2. So I know that the angle difference between the two, we know this is actually 5.2 degrees. Does that make sense why I went ahead and subtracted the decimals? So actually they're not too far off, right? Okay. And we would kind of expect it to be that low. Remember, this one was just a little past 29. This one was a little past 35. So I just now need to figure out 5.2 degrees, just like we've done before. I want to convert it to radians. Okay. So I'm going to go ahead and take what's in my calculator, the 5.2. I'm going to multiply it by pi over 180. Oh, thank you. Yeah, I didn't hit the pi. Thank you. Genevieve. There you go. Okay. So let's see if I can hit that pi again. There we go. Pi over 180. So I'm getting 5.2 degrees to be about 0.091 radians. Okay. 0.091 radians. So I'm going to come back over here. Okay. So my arc length S is going to be, now what do you think the radius is? (3,960). Because imagine this right here, the vertex, that's the center of the Earth is what it should be representing. We're looking at kind of a cross section of it. So 3,960 miles times theta in radians, the 0.091 radians that we just found. But remember, once you go ahead and introduce a unit of length, the radians kind of disappear. Okay. Now, see, I went ahead and rounded it so I could write on my board, my paper, what my work is. But I'm going to use the value in the calculator times 3960. Oop, didn't do it. Times 3960. Okay. So I'd say they're about 359.4 miles from each other. 359.4. Now, let's take a step back for just a second, because normally in these problems, when you're finding the distance between objects, you're going to use a straight line. Is everybody okay with why it's a curved segment? Okay. Because it's on the surface of the Earth. And remember, it's not a perfect sphere, but it's spherical. Okay. To us, the change is so gradual, we don't notice it. It would almost seem like a straight line, but these great distances on the Earth, it is going to be a curved segment. Okay, good. Okay. I know there are still individuals who believe that nowadays. Brandon, are you one of them? Okay.
Don't let her theory voice.
Are we talking about torus Earth?
Velociraptor Earth theory.
How come Earth is what?
How come everything's not like rolling down?
the Earth on a hill, you just stop.
Good old gravity.
If the Earth was flat, cats would have knocked everything off of it by now.
Yeah.
That is a really good point. You know, cats are jerks.
Yeah.
You know, my cat, he's a jerk. All my in-laws who came into town this weekend, every time they walk past, I'm like, then go. You know, get out of the room if you don't like these people. You know, but he's like, no, I'll do what I want because I'm a cat.
Maybe the cats are.
No, I've known these people for years. As far as I can tell, they're good people. I actually do like my in-laws, so that's a good thing. I know you have all these jokes about, you know, people not liking their in-laws, but I really do like my in-laws. They're good.
Do you believe donut Earth
Because they
theory?
can't knock in
The donut Earth theory?
Yeah, the sun rises and sets through the center.
Wow.
There's also
And it-
are now believing that Australia is fake.
What?
Yeah, we say.
There are people who seriously believe that?
Yeah,
Yes.
we think that Australia doesn't exist. The people that live there in conspiracy, the government's in a conspiracy, every pilot in the world is in a conspiracy.
True. You know you say both.
Kangaroos don't exist. The platypus is a myth.
Wow. You know, the only thing I say to that, I mean, you know, our country was founded as a melting pot on free ideas. And I always like to say, you know, you are free to absolutely believe whatever you want to because this is America, but you also have the right to be wrong. So
You're free to be stupid.
I don't say that. That's not for me to say because I do some pretty stupid things. I'm not gonna, you know, judge anybody else.
I hammocked off the side of my car in the parking lot.
You hammocked?
Yeah, I have
What, you hooked a hammock to your car?
to the same side on like the roof rack.
Didn't yours fall last year?
No, that was whenever I was hammocking between two different cars.
Okay.
The cars weren't moving, to be fair.
Oh, that's okay.
They should have been. That was the problem.
That would have
They
been
wouldn't fallen.
more impressive. Hey, there you go. I mean, these are the questions that keep philosophers up at night. You know, like why does a bald man buy shampoo?
Without people.
I mean, you don't know. You don't know. We'll never know. We'll never know the answers.
Can we calculate it with that?
I'll bet we could. I'll bet we could. All right. You know, we could find it. We could work a statistics problem on that. We could all get a Tootsie Pop and then just start 1, 2, 3, and then take the average of, you know, we got a good number of people in here.
Let's do that.
There you go. That'll be a Friday activity. Okay.
Like, are we gonna have the small ones or like the big ones?
Oh no, it had to be the big
Go all
ones.
the way.
Got to be the big ones, yeah.
Or unless you could find.
That's a good point.
Take
You know,
fraction.
Genevieve was saying, are you just licking the one side, or are you like doing the whole mouth? You know, I mean, you know, these are variables we'd have to think about if we're going to go ahead and perform.
Each take like a fraction of the Tootsie Pop, like 1/16, and see how many like it takes to do 1/16 of a Tootsie
Yeah, but how would we know when we're 1/16 in exactly?
I don't know.
And I mean, would the
Math.
yeah, I mean, we'd have to do quite a bit of analysis beforehand to make sure that all of the size of them are consistent. Like, find what's the error approximation.
That's true.
Yeah. There's so much math involved in candy. There you go. Hey, Jenna.
Okay, so I don't know why this is happening, but like there are kids sending like emails to our school email, and like it won't go away.
Yeah.
What, right now?
Too.
Yeah.
What emails?
Just like
They just send random
they're
videos.
like let's be in a group chat.
Oh yeah.
Like I even like reported it as a spam and it still wouldn't go.
What's on the videos?
Just random stuff.
Are you talking about like something you would find like a viral video?
No, it's just like a whole bunch of kids like text each other that's in the school, but like
It's like me.
it doesn't. No one knows how it happened. It's just,
Yeah,
It
it's
happened.
school-wide.
Yeah, it just
Okay.
happened.
It's like Tumblr, but
What's Tumblr?
Wait, do you want to see? Cause I'll pull
No, I'm good. I'm good. Yep. Okay. It's just annoying.
Yeah.
Is any of it funny? I
Until
don't
it
know.
becomes bad.
No.
Until it becomes. There you go.
I mean, there's probably 30 times the entire script of the V movie has been sent in there.
Yeah.
The B movie. Oh, is the Jerry Seinfeld one?
Yeah.
Okay.
You like Jen?
Oh, hey, look, math.
Cool.
So we're almost done. We're almost done.
All recording.
Oh yeah, we are recording. We've been talking about this the whole time.
Watch this video.
So some earthly discovery. Some people are going to be like, I did not know that. The earth is flat. Okay. Compute the length in feet of an angle measure of 1 minute on the earth, given that the radius of the earth is 3,960 miles. Okay, so a couple things here. So imagine, and I'm not going to be able to draw this very well. Say we do have a, okay. Can you kind of imagine that as being a sphere? Okay, let's say you can imagine a sphere, and let's say we have a point on that. This is the Earth. So as it rotates, what we're looking for is the distance it's going to travel in 1 minute. Basically, the arc that's created from its movement of the spinning. That's what this question is asking. Okay. So there's just one conversion that we need to go ahead and take a look at. We've got 1 minute. Does anybody remember that conversion? 1 degree is how many minutes? Ooh, a little higher. 60. Okay, 1 degree is equal to 60 minutes, right? But see, we're starting with theta equal to 1 minute. So why don't we just go ahead and divide through? Wouldn't that tell me that 1 minute is equal to 1/60th of a degree? Okay, so that's what we have here. So we're starting with 1 minute, but because of the conversion, we know we have 1/60th of a degree. So this is still just arc length. It's just imagine a point is on the Earth, and the arc is created as the Earth spins. Okay. We still have the radius as the 3960 from the previous problem, but there's just one thing I'm forgetting. Remember, theta has to be what? It's got to be in radians. So I'm going to take the 1/60th of a degree, pi over 180. Is everybody okay with how I got this 1/60th? Okay, so let's run through that again. So Lily Bell's a little off. We remember from a couple weeks ago when I introduced degrees, minutes, seconds, we had a table that provided me all these conversions. And one of them is that 1 minute is, 1 degree is equal to 60 minutes. Okay, so what I'm trying to do is find what 1 minute is in degrees. So here, if I'm looking for 1 minute, well, I just go ahead and divide through by 60, because what's 60 over 60? 1. So that'd be 1 minute, right? But over here, I'm going to have the 1 degree divided by 60. So I know that 1 minute is equal to 1/60th of a degree. Does that kind of help? Okay. Just like what we're going to do in just a second on the second problem, does anybody remember 1 degree is how many seconds? 3,600. 3,600 if you want to say it that way. Okay, seconds, right? Well, this one is talking specifically about 1 second. So what can I divide by here? The 3,600, right? Because I want to show 1 second. So I'm going to go ahead and divide by 3,600. Well, those cancel, and see, that gives me specifically 1 second, which is what we want. So that tells me that 1 second is 1/3600ths of a degree. So that's what I'm going to use for the second problem. Up here, we were talking about minutes, so I only had to divide by the 60. Okay. So let's actually see what that is. In fact, if you multiply 60 times 180, I think you're going to end up with 10,800. Is that right? I believe so. Let me try. So 60 times 180. Math. 10,800. Yeah.
How'd you know that on the top of your head?
Well, yeah, a couple things. I've really taken the time to try and practice and improve myself, but also I've done this lesson 3 other times today, so I know. That kind of takes away the magic of it, but it was still pretty impressive for a second, right? Okay. Anyways, 10,800 pi over that is going to be my radians. And now let's find the arc length. S is equal to the radius that we're given, 3,960 miles, times pi over 10,800 radians. And remember, as soon as you introduce a unit of measurement, the radians just disappear. Okay. So let's see here. 3960 times pi over 10,800. So let me clear all this out. Document B. 3960 times control divide. We'll get pi. Oh, hit the wrong thing. Over 10,800. Okay. So when I do so, I'm getting about 1.15 miles. Okay. But now are we missing anything? It wants it in feet, right? Okay, so let's say I'm going to go ahead and write this out, 1.15 miles. Now think about our conversion last week. If I want to get rid of the miles, where would you have to be? At the bottom. So in 1 mile, how many feet are there? 5,280 feet. See, the miles cancel, and we'll have feet. So all I have to do is multiply the answer that I got in miles by 5,280. So let's see what that is. Times 5280. So I'm getting about 6,082 feet. Okay. 6,082. All right. Now there's still one problem left, but we'll go ahead and take a look at that tomorrow. And let me give you your assignment. Okay. This is due on Wednesday. This is due on Wednesday. So I'm thinking I really wanted you to have a little bit of time in class to work on this, and unfortunately our flat world discussion and whatnot kind of derailed that. So I will give you some time tomorrow in class to go ahead and work on it. We could probably do a problem or two together. Okay. There we go. All right, now remember when you come in, this is going to be something we'll be doing pretty much every day, are going to be the happy minutes. And I know it's going to be frustrating in the beginning. I know some people don't like it, okay? But it's going to turn out okay, I promise you, okay? It's going to get better, okay? All right. So